Welcome back to the deep dive. Okay, if you feel like the goalposts for artificial general intelligence are moving almost weekly, well, you're definitely not wrong.
It feels that way, doesn't it?
It really does. So today we're going to try and cut through some of that noise. We'll focus on three massive shifts happening right now that really define how AI progress is being, well, measured, embodied, and automated.
Yeah, good focus.
Think of this deep dive as your shortcut, really, to understanding the real infrastructure war that's playing out.
It's true. We're seeing these fundamental changes in how the industry even defines success. It's like we're moving past those abstract benchmarks.
Right, the old academic stuff.
Exactly. And moving into things you can actually measure economically, things that are physically present, systems that are truly autonomous. It's less about answering questions now.
And more about doing jobs.
It's more about actually doing jobs. Yeah.
Perfect place to start then. Let's unpack this big evaluation announcement from OpenAI, GDPval.
Yeah, GDPval. It's a significant one.
It's their third major Evo release this year, right? And it feels like a real pivot.
It is, because unlike the others, this one really tosses out let's say, the academic rulebook.
And replaces it with
An economic one, purely focused on economic value.
Interesting. So tell us about the methodology. How does it break from, the traditional tests like MMLU?
Well, MMLU and others like it, they're heavy on academic topics, right? Fact recall, general knowledge. Good for testing, maybe a smart student.
A very smart student, yeah, but still a student.
Precisely. GDPval, that's GDP valuation, it takes this top-down, very utilitarian approach. They looked at major sectors of the U.S. economy.
Okay.
Ones contributing more than, say, 5% to GDP. And then they zeroed in on the tasks within those sectors that are mostly predominantly digital knowledge work.
Gotcha. So measuring direct economic output, really targeting those white-collar type jobs. What's the scale we're talking about here? Is it comprehensive?
Oh, it's massive. We're talking 320 distinct tasks, high-value tasks.
1,300, wow.
Yeah, across 44 different occupations. Think financial modeling, complex legal drafting, detailed market analysis, stuff like that.
So real professional jobs.
Exactly. And here's the kicker, the really crucial part. The benchmark isn't college grads or, random contractors.
Well, not just anyone.
No. It's human industry experts with an average of 14 years of professional experience.
14 years. Okay, that's a serious baseline. That really grabbed my attention. It basically means the AI has to perform almost at a partner level in some fields.
It's a definitionally high bar for actual real-world competence, no question.
And the results they shared, speaking of performance, kind of surprising, weren't they? Early data showing Anthropic's a Claude 4.1 Opus actually leading in most categories.
Yeah, approaching or even beating the human expert benchmarks in many areas. And OpenAI's own GPT-5 high model, at least currently, is trailing Opus on those same GDPval tasks.
Which is, you have to say, admirably transparent for OpenAI to release.
It is transparent, and it makes you wonder, right? Why release a benchmark where your main competitor, for now, looks better?
Well, I think maybe it's twofold. First, it lets them frame the AGI debate on their terms, the economic value terms, regardless of who's winning today.
Okay, sets the stage for the future.
And second, maybe it signals confidence, like they believe they know how to bridge that gap, perhaps with the next iteration.
That could definitely be part of it. And it really brings us back to the why behind GDPval. I mean, the paper itself doesn't scream AGI.
No, they avoided the term.
They did. But you have to remember OpenAI's original charter back from 2018, it defined AGI pretty clearly as highly autonomous systems that outperform humans at most economically valuable work. GDPval looks an awful lot like the scorecard for that specific goal, doesn't it?
It really does. It makes that abstract 2018 definition suddenly very concrete, very measurable.
Exactly. So you can almost see the roadmap. If some future model, GPT, whatever, next clears, say, a 50% confidence level in these pairwise comparisons on GDPval by maybe mid-2026,
then by their own 2018 definition.
They could argue they've met their standard for AGI. They've tied intelligence directly to economic outputting, which, is powerful for focusing investment.
But does raise questions.
It absolutely does. Should intelligence only be judged by its ability to contribute to GDP? That's a whole other conversation.
Definitely shifts the focus from, theoretical physics problems to quarterly earnings reports, in a way.
Pretty much.
Okay, but that digital knowledge work, the GDPval stuff, that's only one side of the coin, right? The other big piece is embodiment, physical action.
Physical world, yeah.
which takes us nicely over to Google DeepMind. They just unveiled Gemini Robotics 1.5. So we're shifting from the analyst to the skilled technician, maybe.
That's a good way to put it. And look, the jump from digital knowledge to like physical mastery, that's arguably the hardest step in AI.
For sure.
So Gemini Robotics 1.5 is built on this entirely new embodied reasoning stack. Think of it as a specialized brain built on top of the Gemini 1.5 model.
Okay, an embodied reasoning stack.
Yeah.
What does that actually give the robot?
Well, technically, it's a VLA, Vision Language Action Planner, combined with ER, or embodied reasoning. But let's skip the acronyms.
Please.
It basically means the robot can see and understand its surroundings, understand complex instructions given in natural language, and then plan out the sequence of actions needed to achieve a goal.
Okay, so it sees, understands language, and plans actions.
Yeah.
What kind of capabilities does that unlock?
It brings several key things. Long context, so it can remember complex, multi-step tasks over longer periods, like hours.
Right.
Sophisticated tool use. Spatial temporal planning, understanding objects moving through space and time.
Which sounds crucial for the real world.
Absolutely. And another really critical bit, the ability to transfer learned skills across different robot bodies. The AI learns the task, not just how to move one specific set of joints on one machine.
That transfer learning seems huge for scalability. What did they show in the demo?
The main demo focused on sorting a pile of laundry.
Laundry. Okay,
Yeah.
sounds mundane.
It sounds mundane, but think about it. Sorting laundry actually requires really complex visual discrimination, towels versus shirts versus socks, careful manipulation, planning out where things go. It's surprisingly tricky.
I guess you're right. My laundry sorting skills could use an upgrade.
Huh, mine too. But beyond the task itself, some technical folks really zeroed in on an underlying feature that enables this kind of thing, something called robust scene restoration.
Scene restoration. Tell me more. Why is that so important?
Okay, think of it like reloading a saved game state after you mess up.
Oh, okay. The canonical reset.
Exactly. In the real world, robots will fail mid-task all the time, right? Drop something, get bumped. Scene restoration means the robot can recall the ideal predefined state of its workspace, where the basket should be, how the counter should look, and then figure out how to autonomously clean up the mess and get back to that state before it continues the main task.
Gotcha. It's like a self-tidying capability.
Well,
Without that.
without it, any long, complex household task is basically doomed after the first small error. It's a fundamental building block for making robots practical in messy, real-world environments. It minimizes that cumulative error.
That makes total sense. It's the kind of background competence you need for anything persistent. And doesn't this tie into other DeepMind work, like the VO3 project on video models?
It absolutely connects. VO3 showed that these large generative video models, just by learning to understand scenes, physics, how things move and interact, they start exhibiting broad zero-shot skills.
Meaning they can do things they weren't specifically trained for.
Exactly. Tasks involving perception, physics, understanding, manipulation. They use this technique called chain of frames, which is kind of like a visual version of chain of thought prompting. Better world models, better physical action, it all links together.
Okay, so we've got new economic metrics with GDPval and new physical world control with Gemini Robotics. Let's pivot back to the digital world now, but focus on pure automation, the agentic coding arms race.
Yeah, the race to build the best software agent, the one that can just take a high-level goal and run with it.
This area feels like it's moving incredibly fast. Productization seems key here.
It's probably the fastest-moving area right now. We're way beyond simple code completion. We're seeing agents that basically simulate an entire developer environment.
Like Moonshot AI's Kimi. They just launched that OK Computer mode.
Right. That Kimi agent, it acts like its own little OS-level entity. It's not just a chatbot.
OS level. What does that mean in practice?
It means it has its own virtual file system, its own terminal access, its own dedicated browser instance to work with. This setup lets it handle really complex single prompt requests,
Like what?
like generating a complete mobile-first website from scratch, or building a fully functional data dashboard from, say, 1 million rows of data, all autonomously without constant human intervention. It mimics the whole workflow.
That sounds incredibly powerful, sort of like vertical integration for agents. But then you have others, like Factory AI, taking a different approach with their droids.
Exactly. Factory AI is going for a model-agnostic strategy. Their droids are designed as software development agents that can work wherever a human dev works: command line, IDE, Slack, browser.
So less about controlling the whole stack, more about integrating everywhere.
Precisely. Flexibility and integration seem to be their focus, and it seems to be working. They just pulled in $50 million in funding.
Wow.
And they're apparently #1 on Terminal Bench, which is a key benchmark for how well agents perform tasks in a command line environment. So it shows that integration and platform reach matter just as much as the raw intelligence of the underlying model.
And GitHub Copilot is right in the mix too, now with a public preview of its own CLI agent, a local terminal agent.
Right, bringing Copilot capabilities directly into the developer's terminal.
And crucially, you mentioned that agent supports something called the Model Context Protocol, or MCP. This feels like where the infrastructure discussion really heats up.
It absolutely is. You could argue MCP and related infrastructure is the hinge upon which this whole agentic future swings. The arms race isn't only about making smarter models, it's about building the standardized plumbing that lets those models actually use digital tools effectively and autonomously.
Okay, so Google's announcement about the public preview of Chrome DevTools MCP, that's a big piece of this plumbing.
It's arguably the foundational piece for making autonomous web agents truly capable.
All right, break this down for us. MCP, Chrome DevTools. What does this actually let an AI agent do? This sounds pretty technical.
Okay, think of your Chrome browser. Under the hood, there's a powerful set of controls that developers use for debugging and testing websites. That's accessed through something called the Chrome DevTools Protocol, or CDP. Tools like Puppeteer use it for automated web testing.
Right, for automation.
But until now, AI models trying to use the web were kind of clumsy. They were often just scraping screens or using limited, brittle APIs. Lots of guesswork.
Lots of errors, I imagine.
Tons. What the Chrome DevTools MCP server does is expose those deep CDP Puppeteer controls programmatically to an AI agent.
So the AI gets direct access to the developer controls.
Exactly. It gives the AI agent the autonomous ability to inspect and manipulate a live Chrome browser session with incredible precision. It can navigate pages, dig into the underlying code, the DOM, check network requests, run console commands, take screenshots, essentially anything a human developer can do using DevTools.
So, put simply, the agent can now use the web browser like an expert developer would, not just like a casual user clicking around. And it can do it automatically without needing step-by-step instructions.
That's the core implication. This could be the shift from the prompt engineer needing to guide everything towards truly autonomous agents that can execute complex web-based tasks.
It standardizes the control surface for the web, which is huge for building reliable agents and actually evaluating them properly.
Right. It transforms the web from just a source of information the agent reads into an active environment the agent can work within to achieve goals that might even overlap with those GDPval tasks we discussed earlier.
That connection is fascinating.
And of course, standardization like this also sparks new technical debates, like how should MCP bundle complex web resources together, the HTML, the images, the CSS, so the agent gets the full context it needs to act accurately. These are the nitty-gritty infrastructure problems being solved right now.
Okay, wow. We have covered a lot of ground today. It really feels like three defining threads are emerging.
Definitely.
First, we saw the very definition of AGI, or at least its measurement, shifting towards concrete economic value with OpenAI's GDPval.
Moving from the abstract to the economic, yep.
Second, we tracked Google DeepMind, pushing the physical frontier with Gemini Robotics 1.5, enabling more complex long-horizon tasks through better vision, language, and action planning.
Embodiment getting more real.
And finally, we dove into that accelerating software agent arms race, crucially underpinned now by standardized infrastructure like Chrome DevTools MCP, which gives these agents real power to act autonomously online.
The automation infrastructure layer. Yeah.
So what's the main takeaway for you listening to all this?
I think the takeaway is pretty clear. Pretty much every major development we're seeing points towards a systems level shift. AI isn't just a reactive tool you poke anymore.
Right.
It's rapidly evolving into an autonomous system, one capable of independently taking on really complex, economically valuable roles both in the digital world and increasingly in the physical one, too.
Which leads us directly to our final provocative thought, something for you to chew on after this deep dive.
Okay, let's hear it.
Given that this new infrastructure, like Chrome DevTools MCP, allows AI agents to autonomously use the web to actually perform the kinds of tasks that are currently measured by economic metrics like GDPval. What comes next? What new, maybe non-economic metrics will we need, perhaps as soon as next year, to truly grasp AI's impact beyond just GDP, its impact on human creativity, on knowledge creation, on society itself?
That's a big question, measuring the unmeasurable almost.
It's definitely something to think about as these agents become more and more capable, more integrated into everything we do.